So what would be, so what would be f star 1 5, abstract version of this? So it's going to be p15 plus sum of over those, states which leads to 5, okay, and which are other than 5. This is important. Okay. And the p1k and f star k5. This is what is going to be. So what is p15? So what is the probability that you're going to reach from state 1 to 5 in one step actually? Because that's what it represents. It must be 0. This goes away. Okay? So what other values this k can take actually? So in other words, I can reach to, k to some state to 5. So this could be 1 itself.
But sir, 1 is 0 we saw.
I'm sorry? Okay, so since you have a p15, so it's going to be 0. So in other words, I can reach from 1 to 5. I can reach from 4 to 5. I can reach from 2 to 5, and I can reach from 3 to 5. Okay? So for the make of and you just have to think that, okay, which of these probabilities are non-zero actually out of this 1, 2, 3, and 4. For example, if I say, so if I explicitly write this expression, is going to be p12 and f star 25. Okay, that would be 1. Plus, what would be other? So p13 and f star 35. Reach from probability that you reached from one step to the step 3 and then 3 to 5 and some number of steps, because that's what it says that. Probability that you reach from state 1 to state 3 in one step and from 3 to 5 in some number of steps, which is unknown to me. Okay. Plus p14. Okay. And f star 45.
Sir, 1 भी आएगी सर जो पहले हम 0 कर रहे थे, because you can reach from 1 to 1.
And then you have a p11 plus and f star
1 to 5.
1
5.
Okay. So I know only these two terms would survive, because you can't reach from step 1 to step 3 in one step. You can't reach step 1 to 4 in one step. So the only a possible expression, so that was the equation that you're going to get is what? Is this. So you're going to have a f star 15 is 1/2. Okay. F star 15 plus 1/2. F star 25. Okay, so this is going to be. Now, from this I can also deduce that f star 15 is basically f star 25. Okay? But I'm interested in computing explicitly what is f star 15. So I need to compute f star 25. Okay, I'm forced to compute f star 25. So the question is, what would be f star 25? So you can show that f star 25 is going to satisfy 1/2 of f star 35 plus 1/2 of f star 45. And you're going to see this is kind of an invitation to the new problem, that what is these two probabilities. So let's see what is f star. You can see you're going to get a recursive relation actually, that you just backward problem actually. So you will compute one probability and return back to basically what you want. So f star 35 is 1/2 of f star 15 plus 1/2 of f star 65 actually. And what is the probability f star 65? I can explicitly talk about it. That what is this probability? So this must be, you can't reach from 6 to the state 5. So this must be 0. Okay. And And what did you get? So if this is 0 and
55 is half of.
so f star the 35 is the half of the 1 5, so I can substitute it here. Okay, and I can do what?
One thing I'm missing. 1 5 equal to 2 5.
F star 4 5 is missing. So f star 4 5 is going to be 1 half of f star 1 5 plus 1. No, I think I wrote it wrongly.
Yes, sir.
Okay, so this is f star 4 5. So what is f star 3 5? So f star 3 5 is 1 upon 2 f star 3 5 plus 1 half. Okay? So if I have this system, so this is going to show me that f star 4 5 is the half of f star 1 5, so I can substitute it here. And f star 3 5 tells me that it's a half of f star of 3 5 plus 1 half. You can convince yourself that this must be true, so that means that you're going to get the value of the concrete value of the f star 3 5 actually. And then substitute it back here. Okay, and what? So you got another equation for f star 1 5 and f star 2 5. Solve it, and you're going to get the values. Okay. So it's just a simple system actually. It's not a complicated stuff. So what you get is f star 1 5 is basically 2/3 actually. Okay. So it's a 2/3.
So how we are writing 1 5 is equals to 2 5? F star 1 5 telepel is on the side.
Yes, so what you can do, you can take this on the other side and subtract and just
1 5 to
that 2 by 2, so you get. Okay. Alright, so now we also know that if you give me a transition matrix, I can compute such probabilities. Okay. And now I would like to, I'll just mention results actually. Okay, probably I'll do one of the results or maybe none of them. I'll just give you you can read the proof for yourself. So now you are mature enough to read the proof for yourself. You can read the proof for yourself. I'll just state the results, some of the key results, and then talk about their applications. Okay, so what is the next thing that we would like to do? So one immediate thing that you would like to do once you have such probabilities, now you can talk about the transients, recurrence and the transients of this statement. Okay, once you have these probabilities, you can talk about the recurrence and the transients of this statement. Okay, so give you. And hence, these first passage probabilities are allowing you to classify the chain in another manner, which is which of the states are transient and which of the states are recurrent. It's a very interesting result. You can see it. I'll just talk about its consequences. From the book. So this says that the state I in a chain is recurrent if and only if sum of probabilities that you will return, you will start from the state I and return back to the step I in n steps, and this sum is taken over, from 0 to infinity, and it blows up actually. Okay. It blows up. So state I is recurrent if and only if the probabilities that you will return from the state I to state n explodes. Hence, this tells us about you know, so the transience is kind of opposite of recurrence. Hence, you can say the state I is transient if and only if this guy is finite. Okay. Infinity n is finite, and if it is finite, like this series converges, and this converges to this interesting number, which is 1 over 1 minus the first passage probability from this, state I to this state I. Okay? This state I to this state I. So this theorem is allowing you, kind of playing a decisive role, okay, in knowing that whether a given state in a chain is transient or recurrent. Okay? So compute their n-step probabilities and see the pattern, whether this series converges or diverges. So if it diverges, it explodes, you are talking about an, what do you call recurrent state. And it makes sense actually. Think about it. What do you mean by these probabilities are diverging? In other words, the probability, so the probability that you return, okay. So when a series converges, so we have something, what do you call, so can you give me a necessary condition, not sufficient, a necessary condition for the convergence of series vector? So a necessary condition for the convergence of series is that the sequence through what the series is made, that should go to the zero. So the series an, if it is convergent, then the an would go to the zero. What do you call this so-called divergence test? Okay. And if an is not going to zero, this would diverge. Now think about it. If I'm saying, like, why this is showing that, the state I is recurrent. What this has to do with the recurrence of the state? So think about it. So Pii in one step, that may be a smaller number, but since this series is diverging, that the next number, the Pii in two step, either is going to be same as previous number or is going to increase actually. It's going to increase. Okay? So think about it. So Pii in one step could be a number. And the Pii 2 is, could be another number. Okay? Okay, maybe even if you can say that for the finite amount of time, it could have any behavior it could want. But the tells of this sequence, okay, are going to do what? They are going to have a behavior that this number Pii is getting bigger and bigger and bigger. And what do you mean by Pii getting bigger and bigger? It means that you are having a more and more and more probability that you're going to return to the state I actually. So it makes sense. Okay? So it makes sense. So this series explodes, the state is recurrent. Okay? And if this series is finite, okay, then the state is transient and the series will converge to this number. So in other words, if you know this number, you know the series actually. Or if you know the series, that's another way to compute this F star I actually. Okay, so both ways you can think about it. Okay.
सर PI ये probabilities है, वन से तो ज़्यादा नहीं जाएंगी ना?
नहीं जाएंगी, yes.
फिर सम बड़ा होता जाएगा ना?
नहीं. So here's the thing. If this series is finite, this means that this number should go to the zero. And what does it mean that this number would go to the zero? That the probability would be less and less and less as the time steps proceed. Okay. Brush up your real analysis. So you learned those results because you could apply here. Alright. Now getting into the proof of it. Okay, maybe the next result. I'll apply it in a moment to a particular situation. You can read this proof, is very easy, so just a few lines proof. Okay. The recurrence and transient transients are class properties. That's an important thing that you can read also as proof. It's just a one-liner proof that recurrence and transients are also, what do you say, class properties. So in other words, if you see, especially for example in case of a finite state Markov chain, okay, you can split it into that, okay, these states are recurrent and these are transient. Or if you can split it into the class, two classes, and you know among, for example, these classes, one of the state is, for example, transient and one is recurrent, that means the entire class is transient and recurrent. Okay. Another result, probably quickly write it proof. It's an interesting one. You can use it and wish you can see it through for yourself as well. So if I is recurrent, so this theorem is kind of linking, this recurrence and transience with, essentiality or inessentiality of the state actually. So imagine I have a recurrent state. Recurrent, and I leads to J. Okay. Then I and J would intercommunicate. That's the first thing. And not only they will intercommunicate, but there are probabilities that you are going to reach from I to J, and you are going to reach from J to I must be what? One actually. Intercommunicating should be one. So I can say if I is recurrent, then I is essential. Okay, that's what essentially, this part is telling you that, I have a recurrent state that leads to J. Okay, then I and J would intercommunicate. Okay, and these would be their probabilities, and this means that I is essential. Okay. This is what an interesting thing is. By the way, this result is not claiming that when I leads to J, the J would be also recurrent. It's not telling you. It's just telling you that I and J would intercommunicate. Okay, because it is possible that I and J are sitting in two different classes, subclasses. Classes. Okay. Okay. You get it? Right. Here's a little proof of it. So, okay. So, what is given? So, I is recurrent actually. So, if I is recurrent, I I can say that Fii star is 1. So that's what is the definition. That's what the definition is giving you. Now consider the first step decomposition. Okay, of say F star say K I, okay, F star K I, where K is an another state actually from where you can reach to the I. Okay. By the way, I'm assuming, so I'm in the assumption that I is recurrent and I leads to J. So eventually I'm going to reach to the, I'm going to talk about the J. Okay. So think about F star Ki, so I can say this would be Pki plus summation over say L that are different from I, P, K, L, and F star, and okay. So this is going to be the sum. Now, what can I do? By the way, can I combine them into a single sum? Can I say that all this is the sum that is over L and PKL, okay, and F star Li? Can I put them together? Why must we able to put them
So
together?
PK is already there, so you can use times 1
Yes.
F star II.
Yes. Okay. So I can put this here. And now I would like to do what? Now I would like to substitute the value of okay, so this is Fk star I. So I want to substitute a value for F star Li. Okay. So if I substitute, I have F star Ki, okay, sum over L, I have PKL. So what would be, so in the similar manner, I can have the substitute for F star Li actually. So let's say that this sum is over G, okay, and I have what? PLG, okay, and F star G I. Okay. So the probability that you're going to reach from this, state L to G, and then G to I. Actually, this is one step, and this eventually. So you have it. So this is like a double sum, and what I want to do, I want to switch these sums, and I can switch these sums up too. Okay. So just a simple laborious work. You will see that where we are heading. Giving you what I would like to show, I would like to show that J and I intercommunicates and this identity. Okay? This is true. So I would like to switch these sums. I can. You can think carefully about it, that why I am allowed to switch the sums. Okay? So if I am switching the sums, I'm going to get PKL and PLG, okay, times F star J. So what does this expression is telling? So in one step I reached from K to L, and in the next step I'm reaching from L to G, and then from G I'm eventually reaching to this entire. Okay? what would be this expression? If I have to write it explicitly, I can write this as that this is PKG, okay, but in the two steps actually, and F star GI. Okay, so F star GI. Again, don't forget that we have this F star K I star. Okay? Then I can do what? I can substitute the value of F star GI. I'm going to get a similar kind of an expression. I'm going to switch some agains, and I'm going to have a, two steps are, taking me from K to G, okay, and then two steps are taking me from, for example, K to L and then L to G actually. So I'm going to have a third step. You get to the point. So I can reach from K to some other state, G or H in 3 steps. Okay, so if I substitute, if I do what I did here, okay, then I can have a, a probability that is going to take me from the state K to some other state that leads me to I, but in the 3 steps actually. Okay, so I can keep on doing it, and I can get what? Finally, this expression, which is F star Ai is the sum over G. And I'm reaching from I to G in the n steps, okay, n star G to I in some number of steps, okay. Keep in view, this K is arbitrary, okay, so I haven't have any assumption on the K actually, so this expression is in itself an independent, you can keep it as a lemma actually or something like that. So this expression is true for all K in the state S actually, without any restriction. Okay. In particular, if I take this K to be I, so let's take that K to be I. So you're gonna get it. So F star I, okay. I know this is equal to 1 because the state is recurrent. So the other side is going to be some reaching from the state I to J in n steps. Okay.
K to GI.
Yeah, K to G. Okay. So I to G in n steps, and F star from G to I in some number of steps. So you're gonna get this. Are you getting the point? Okay. Now what is this? Now, can I say, okay, now since the sum of, so you take an n step transition matrix actually. So I know 1 step transition matrix, which is transition matrix, is a stochastic matrix actually, in which the sum of the rows of properties is 1 actually. But this is also true in p and p square and p to the n, so it's true in all actually. So I know about these PIGs in the n step. Okay, this is equal to 1. I mean, if you take all these probabilities and you take you fix a g in particular row, this sum is going to be 1. So I'm gonna use this. So what I want to do, I want to substitute this expression here, okay, and bring that sum on the other side, and apply distributive law, take this guy outside, and you're going to get something interesting as a result. Okay, so let me just finish it. So see, the proofs are like that. They are easily readable proofs, not so much difficult. So if I substitute this here and then bring the sum on the other side, I'm going to get what? I'm going to get Pij, so the Pij reaching from the I to j in the n step time 1 minus F star Gi, and this goes to 0 where the sum is over Gi. Okay? So you're going to get this. Okay? this series is going to 0. So does it tell you something about this? The representative of the series, maybe the sequence that is. So this must go to 0. So Pij n times 1 minus f star gi must go to 0 as g goes to infinity. G goes to infinity? No,